Good morning, Rob. I got a bunch of work in this, and I still, I'm not even sure if I'm to the halfway point if I really wanted to turn these into drawings. Um, so before I got too carried away, I wanted to show you what I was thinking and let you veto it, show it to some of the guys there and see if it's worth pursuing. Labor costs will go to damn near nothing. It'll be just an assembly job. I've been pricing steel along the way. You're going to have at least $10,000 in steel for two of these, at least minimum. Um, so it's still a pretty hefty job. And then there's going to be some water jetting on there, some laser work. Um, but I guess to get to it, I kept the shaft the exact same. So if I make you a replacement shaft for my design or their design, wouldn't matter. They'd both be interchangeable. But when it comes to making this box, the way they had it was they, would weld all the six sides together, and then they called out the perpendicularity on the drawing and the surface finish, and so they would apparently go back in and machine this enormous thing into a perfect cube. Then it only makes sense from there to line bore the holes so that you get everything straight there. It's just there's not that many machine shops with large equipment like that. So let's say we made a much more manageable size ring. I can thread the ring, and then the inside plate I would cut. So I don't every pierce through a 2-inch plate costs you money. These are all 2-inch plates, just like the OEM. So every pierce costs money. So instead of doing piercing holes, I just did slots everywhere. But let's say you use 3/4 inch bolts, and we bolted a ring there. I've got 1-inch slots, so there's plenty of room. And then you would basically cut these holes in the side so that you can get a wrench in there. But basically, you'd put the shaft in, tighten everything down, and then you know that they're aligned. Take the shaft back out, and you could probably get in there a little bit better with the torque wrench and really get all these bolts tightened. So I did that on both sides. And then the side plates are pretty self-explanatory. That's what's holding the whole thing together. Let me take this top off here. I've got everything held together with these 4-inch by 2-inch by 2-inch blocks. Those will get threaded in the mill, and then your bolts would come through and hold it together. And that way we have an opportunity to square everything up. I've got a gap in between here. So like I said, once again, there'd be plenty of opportunity to tighten everything down and get it where you want it. And then if you have to go back later and start adding welds, you can. And then the same thing for these the bronze sliding blocks. I would bolt those to the face of this corner piece so that I could move it forwards, backwards, up and down, and really get all four corners. I didn't model the other four corners of those sliders, but all of those would be totally adjustable so we can get it perfect without having to machine it. I even gave you special slots just to put a pry bar in. So this slot is doing nothing, but it allows you to put a pry bar in here and get that spread out where you need it to be, so you can tighten down where you need it to be. So you can put the block on the machine, tighten everything down, get it sliding up and down really nice, put your shaft back in there. And then on the front plate, so many ways to skin this cat. I looked at rings inside of rings with pipes and tubes and all kinds of different things. And then it finally dawned on me that what we were trying to do really didn't demand that much volume of steel. So how about instead of making it out of, 6 pieces of flat stock and tubes, or one giant piece, or 2 solid pieces, or whatever, what if we just did some plates and bolted together like a bicycle wheel? So I think I got multiple sets of holes here, so every other one would be bolted together with an inside set or an outside set. And I put some, this is half inch diameter, so that basically you'd use half-inch threaded rod. You would set this contraption on the floor, start putting all your threaded rods through it, and then tighten it up like a bicycle wheel. And all you would need is a few tacks along here, so you're not distorting. I can bore this out really easily. That's also a manageable size. It's got a 7-inch inside diameter, 7 and some change. It's metric, obviously, but I could make that no problem. So then the last thing to mention was the original one had two bearings inside of it and a bunch of spacers, and they also had seals. It got crazy. Um, they've got a seal here, another kind of seal here. I guess they got a lip seal here and a packing seal there. Um, and then they would have had to form some kind of a silicone that cap on so that the grease fitting works. But why don't we just use micropoly? I can get 4 of these bearings inside that same diameter, and so I think we should just use we should micropoly those bearings so that they're permanently lubricated, so you don't need a grease fitting anymore. Don't need seals in the back. And then instead of using a spacer here, I would just use 2 more bearings. I did the math. That's going to push you out to the face, but that only makes this easier to make. So the inside bore becomes a lot easier. I just need one little lip at the back to hold the bearings in, and then my cap gets easier to make, and you've got twice the carrying load that you used to have, and you never have to grease it again. So that's what I'm thinking about for this inside piece. Start with a pipe, bore it out, lay it on the floor, bolt these around it, and once you get those kind of tight, then you could put some tacks on there so you're not distorting it. If this looks okay to you, my cap would be very similar to their cap, so those would be interchangeable. The back cap would be the same. As much as possible would be the same. Those are the 2 radical design changes to get away from so much welding and machining. Let me know what you think, and then I can try to get you a price today. More likely tomorrow. Thank you.